Hi, everyone. So we're back, and you can see the title that we've got up on the top. We're going to go through and we're going to address rationalizing the denominator specifically today. So it might seem a little misleading that today becomes the title of that since we were introduced to that last time. But really what we just want to kind of focus in on is rationalizing the denominator is like an operation, right? It's us manipulating the way something looks through operations in order to have it satisfy that instruction of simplify, to have it make sense. Today, what I want to do is I want to focus solely in on rationalizing. I assume you're good with all of your operations. And really what I want to talk about today is strategies that we can use when we try to go through the process of rationalizing. So I'm making the assumption today that you are good with rationalizing. So what that means then is today becomes an opportunity to gauge where we're at with the material, but also then to try to make ourselves a little bit better, to examine the strategies that we use to rationalize and see if we can become a little more efficient with it. So let's start off at the very beginning. Let's make sure that we're good with it. Let's get a gauge. So you take a look at what you have on the screen right now. There is an expression in A. You've been asked to simplify it. Obviously, that's not an easy one. I would argue to you that's not even middle of the road. This is going to be a difficult one for us. There's a lot involved in that expression. So we get our information from A. Do we match up in the end? We take a look at the strategies we used. But also, if we make some mistakes on this one, that doesn't mean that we don't know anything about rationalizing. No, this would be our doozy. Okay, so I want you to go ahead, simplify that expression, pause the video now. Okay, we're back. So we take a look. We have nothing in common in both top and bottom. So I don't have any option to be able to go through and divide out anything right now. I am stuck rationalizing at the very beginning. We have multiple terms on the bottom, so I need to go through and multiply by the conjugate of that bottom. And to keep the value the same, I have to multiply my top by the same thing. In green, there is our form of 1 that we are multiplying that is most useful. So we then went through and we expanded the top. I've got a 12 root 3 minus a 9 root 6 minus an 8 root 18 plus a 6 times 6. Now, some of you can already see that I've put some of the blinders on a little bit for us to be able to go through. We might have seen it right there, that when I chose to multiply those terms together to get my negative 8 root 18, we could have simplified our radical in the same go. I just think that that's a really big jump for a lot of us, especially today. So I'm going to put the blinders on a little bit and let us see that we could actually just work our way through pretty comfortably dealing with all of our operations and then simplifying in the end. Now I multiply on the bottom. I'm going to be a little more efficient. I chose conjugates for a reason. I know my middle terms will cancel out. Okay. Now I can clean some stuff up. On the top, I don't have any other root 3s. I don't have any other root 6s. But when I now reduce this, I can take the square root of the 9, which is a 3, and I'm left with root 2s all over. Now, before we get to the bottom, you may have noticed that just my experience, I can already see that a root 18 is going to reduce to root 2s. And because of that, I just kind of blindly copied everything else out. It might look blindly, but I knew that I was going to get root 2s from that term, so I saw that I wasn't going to be able to collect anything. It doesn't matter in terms of your process. It might have just added an extra line to your solution. On the bottom, I've got my 48 minus my 54. Okay, I'm running out of space, so I'm coming up here. I have nothing that collects on the top. So I'm stuck copying out and taking time to not make like some silly little copying mistake of changing a sign or something. And on the bottom, I get a negative 6. Okay. I see that -6 pop up on the bottom, and now I'm taking a look at all my whole numbers on top and bottom. I've got two issues that I need to deal with, but I can deal with them in the same go. The first one is I've got a negative on my denominator, so I'm going to have to eliminate that. But secondly, I notice in everything that I just circled, all of my whole numbers, I have a common factor in there of 3. So I'm going to divide out that 3, but at the same time, I'm going to divide out by a -3. That's going to eliminate my negative on the denominator, which fixes my form, at the same time as reducing each term. Okay, when I do that, I'm going to get this term. So, -4 root 3 plus 3 root 6 plus 8 root 2 minus 12 all over 2. So notice by dividing out that -3, I eliminated the negative on the denominator and reduced every single term. I no longer have common factors in everything. Now, you might notice that I wrote that in green. If I was tackling this problem, I would skip that step because I can see that my first term is negative. And when I scan that line, I have 2 other terms that are positive that I could have written in that first position to eliminate having to write down extra operations. So a little bit of forethought is going to say, when I go to divide out that -3, oh, my first term becomes negative. Oh, wait a second, my second term is going to be positive. That instead, what I'm going to do is I'm going to write that second term first, so that now I don't have to write down an extra operation. It doesn't matter which term you write first. Remember, there's no set rule as to which order you have to write your constants your whole numbers versus your radicals. Doesn't matter. Hopefully we got down to that, and I would argue to you that if you got down to that, that is outstanding. I think that if you were able to get down to that line with everything circled in gold, I think you're doing pretty decent. That's telling you you're pretty solid with your radical operations. Okay, as I mentioned at the top, we're going to jump through, and the focus today is we're good with rationalizing. It's about strategy. So I want you to take a look at B. And I want us to maybe try to examine what we could do on B. I don't want us to actually work our way through yet. So when I ask you to pause the video, what I want you to consider is, what would you do first? And be committed to that. So have some options as to what you think you could try as your first line, and then make a decision about, okay, this is what I'm going to do. Okay, so let's give that a shot for B. Pause it now. Okay, we're back. So the first thing that I'd like us to notice, on top, I can't collect anything because they're not like radicals. But we should notice that you've got like root 20, which we know reduces, root 70. And if we examine the other things, then they may reduce as well. So we have this option of, do we want to reduce our radicals on top? But then we also notice that we've got a root 5 on the bottom. Now, if when we reduce everything on the top, they all become root 5s, well then we'll be able to divide out our root 5s and we don't even have to worry about the radical on the bottom. Or maybe that other strategy was, hey, how about I rationalize it to get rid of the root 5 on the bottom? I hope that we can see we have 2 different strategies to get there. I think, given our discussions over the last couple days, you might know where my kind of advice would lead you. I think we should be examining the first one for a number of reasons. At the very least, look what happens if we go through and we multiply top and bottom by root 5. Can you see that when you expand in that root 5 on top, you're going to get some pretty big numbers? So if at the very least we get to work with smaller numbers, I think our goal should be reducing. I touched on it on the end as well. If we could simplify them all to root 5s, then we could just divide out our root 5s, and rationalizing, the second strategy, doesn't even become part of our solution. That's a big if, but it's possible. So let's get rid of all that stuff that we've written off on the side. And my suggestion to you would be, let's reduce everything on top, see what it works out to be, and then decide where to go there. Okay, I want you to pause the video and take that strategy. Pause it now. Okay, we're back. So maybe we're even past writing down factor trees. I'm going to try to just talk this one out and not write it down, and we'll see how well we do. So I see root 20. I know 20 is 4 times 5. So I'm going to take the square root of 4, which is 2. I'm left with a 5 underneath. I take a look at the next one. Hey, 72, that's 36 times 2. So take the square root of the 36, which is 6. I'm left with the 2 underneath. 125, well, that's 25 times 5. So the square root of 25 is 5. And I'm left with a 5 underneath. And 18 is 9 times 2. So take the square root of the 9, which is a 3. I'm left with a 2 underneath. So I was able to get by without even writing down my factor trees. Know that that's an option. Okay, now that I've done that and I look on top, I have a number of things that'll collect. I can collect my root 5s and I can collect my root 2s. Unfortunately, not everything on top is a root 5. And I don't have a common factor in all 3 terms, so I am not able to divide anything out. But at the very least now, I can see that when I multiply my root 5 over root 5, my form of 1 to rationalize, I get to work with some small numbers. So when I multiply it to the first term on top, I'm going to get a 2 times 5, which is 10. Second term on top, I get my 3 root 10. And on the bottom, I'm going to get my 2 root 5 times 5. There's my 10, and there we go. We do not have any common factors in all 3 terms. We are good. So hopefully you can see that by taking that strategy at the top, again, we're coming back to that question we mentioned at the very beginning. When should I do something? By reducing everything, at the very least, you get to work with the smaller numbers. Okay, let's try another one. I want you to take a look at problem C. I'm going to let you guys go. On problem C for this one, I actually want you to be committed, fully committed to what your strategy is. So I want you to have a goal. The instruction is to simplify. Let's go start to finish on this one. Okay? Pause the video now. Okay, we're back. So what I'm going to do is I'm going to tackle this one 2 different ways. We really have 2 instructions or 2 strategies that we could follow. Those strategies are going to deal with our operations. Then I notice that I have my radicals, so I'm going to have to deal with my root at some point. I also notice that those are on the bottom. So maybe my first strategy is, hey, I'm going to rationalize. Okay, that means that I have to multiply this first fraction by root 3 over root 3. Because that's now going to give me root 3 over 3. Then on my second fraction, I'm going to have to multiply that by root 5 over root 5. And that's going to give me a root 5 over 5. I dealt with my radicals on the bottom. Now everything's rational. But I noticed that I have 2 fractions that I've been asked to deal with. So now my focus becomes, okay, what about the plus in between? Now I have to deal with my addition. So to add those 2 fractions together, I'm going to need a common denominator. That common denominator is going to be 15. That means I have to multiply the top of the first fraction by 5 and the top of the second fraction by 3. I get down to that. I am fully simplified. I do not have a common factor in all 3 terms. I am good. So I want you to notice that first strategy. That first strategy was, hey, let's rationalize. And now that I've rationalized, my denominators are whole numbers, I can get a common denominator and pretty good. So strategy 1 would be rationalize first, then deal with the addition. My other strategy could be the exact opposite. Maybe my focus became on the addition first. So what I'm going to do is I'm actually just going to copy that question down again, just so we don't have any confusion about what I'm writing within the problem. My other strategy is going to be, I'm going to get a common denominator right now. So I've got root 3 and root 5 as my denominators. Well, I know I can always get a common denominator if I multiply them together. So my common denominator is going to become root 15. Okay, well then what did I do to root 3 to change it into root 15? I multiplied that by root 5, so I need to multiply the top of the first fraction by root 5 and the top of the second fraction by root 3. My focus was the addition first, and I just dealt with the addition. But I look at the outcome and I notice that, oh, now I've got a radical on my bottom, so I need to rationalize that. So that means I need to multiply by root 15 over root 15. And now when I do that, I'm going to try to be a little more efficient here. I'm not going to be as blinders. The 15 is made up of a 5 and 3. So when I multiply it in the first case, I can see that I'm going to have 2 5s underneath. So I take the square root of those 2 5s, which is 1 5, and I'm left with 3 underneath. When I expand it into the second radical, I'll notice I'll have 2 3s underneath. So the 2 3s, the square root of that is 1 3, and I'm left with the 5. And on the bottom, I get down to my 15, and there we go. So notice we come down to the same thing, and notice that by doing a little bit of work in my head, I got down to it in the same number of steps. Had I put the blinders on a little bit and just multiplied out, then it would have required one more line to simplify. I'm not arguing to you that either method is necessarily better, or I can't really give you the advice that one method will always be more efficient than the other or less efficient. It's really going to depend on the numbers in the problem. So I think the important thing for us is just to notice that we have options. What does your focus become? Does it become about rationalizing first? Then we deal with the addition? Or would it become about the addition first, and then we deal with rationalizing? Okay, so we're dealing with the when should we do some stuff? When can we do some stuff? What operations do we have at our disposal? Let's try another one. Okay, you take a look at D, and I think D should act like a little bit of a check for us right now. So I want you to go start to finish as fast as you can through D. Pick one strategy. Don't try to do it 2 different ways, and we'll see if we match up in the end. Okay, pause it now. Okay, we're back. Now, I'm going to guess and say that for most people, getting common denominators is probably easier when they're rational numbers. So my guess would be I would have many more people that would choose to rationalize first and then combine their fractions as opposed to the other direction. So I'm going to try to see if I match up with most of you guys using that method. So I multiply the first one by root 2. It's fine if you dealt with 2 root 2, but you're going to guarantee that you're going to have to reduce. By multiplying by root 2 only, maybe I get to avoid that. So my top becomes root 2, my bottom becomes 4. My second fraction, my top becomes root 3, and my bottom becomes 3. Okay, well, one nice thing is I notice right away those 3's divide out in my second fraction. Now, I'm going to take that approach because now when I go to put those terms together, I can just have a common factor of 4. Notice if we didn't divide out the common factor of 3 right away, we're going to get stuck finding a common denominator of 12, and you would have found that you would have had to reduce your fraction. By reducing it right away, I hope to avoid that, and in this case, I do. Now that I can have that common denominator of 4, that means I don't even have to change the first fraction. But I need to multiply the second fraction by 4 to get that denominator. Now, I would hope that we had that as a solution, but as I just talked about, I have a feeling that I would have had a bunch of people that would have found a common denominator of 12, multiplied the first one by 3, and then had to multiply the second one by 4. You'll notice now that within that fraction, you have a common factor of 3 in every single term. And when we do divide that out, we come back up to the red. So something to keep in mind. You pause the video if you need to get a look at that again. I'm going to get rid of that because I think we should be good to be able to jump that line if we're always looking to reduce. Okay, now we jump into E. Same thing. You take your direction, your strategy. We'll see if we match up in the end. Okay, let's pause the video on E. Okay, we're back. So, similar to everything we've said since the very beginning of our radical stuff, I like to reduce stuff as much as I can. So, I look at that 18, and I notice that that will reduce, and I look at the 75, and that's going to reduce. So, if I take my approach to reduce that first, then my denominator becomes 6 root 2 on the first fraction. And my denominator on the second fraction becomes 15 root 3. Now, it's not much help on the second fraction, but on that first fraction, I can divide top and bottom both by 3. That's going to shrink down my fractions. I like that as a first step as opposed to just rationalizing and multiplying by root 18 and root 75 and making our values really big. Totally correct. If you took that approach, it's okay. We'll see if we match up in the end. So just to avoid all that little scratches that I've got down there, I'm going to rewrite out that just so there's no confusion about what you see on your screen. Because we should be able to finish that thing off. So if you'd like an opportunity to finish off on your own, pause it. Otherwise, you're coming along. Now, we made this look an awful lot like problem D. So I'm going to multiply top and bottom by the least amount I need to be able to rationalize. That's going to make the top of my first fraction, or sorry, my whole first fraction, a root 2 over 4. And then my second fraction is going to become a 2 root 3 over 15 times 3, 45. Okay, now I got to get my common denominator. Well, my common denominator is going to be 4 times 45. That's 180. That means I now have to multiply my first top by 45 and multiply my second top by 4. And pretty quickly, we should be good to see that we do not have any common factors in all three terms. And there's our final simplified form. Nice. Okay, so notice we had so many different opportunities to go through there. We could have rationalized in the very first line. If we did simplify first, then maybe we got a common denominator that dealt with root 6s. So many different approaches. Okay, let's jump in and deal with one last problem. So you guys take a look. We've got problem F, and I'm going to let you guys go on F. So we should be good to get down to the same thing in the end. Let's pause it now. Okay, we're back. I think I've done enough to maybe motivate you guys that I think simplifying should always be your goal. Let's try to reduce both of those right off the bat and deal with the smallest numbers. So in that case, my first denominator can be reduced to 5 root 2. In the second denominator, I can reduce that to 3 root 3. Now, this would be an opportunity where I would love to hey, how about we just get a common denominator? Well, I'm not going to because I think it makes it uglier. And I'd like us to be able to match up as we go. But for anybody who did want to get their common denominator is going to be 15 root 6. You're going to multiply that to a 12 root 3 and multiply that to a 15 root 2. Now you just got to take a look and see, can you reduce? And you can reduce that pretty quickly. However, I'm going to bet and say that most people would have then rationalized. Multiply the first by root 2 over root 2. Multiply the second by root 3 over root 3. So that's going to get me a 4 root 2 over 10 minus a 3 root 3 over 9. Okay, we come in on that. And now I notice I can actually do a fair amount of simplifying here. I can divide a 2 out of top and bottom. That's going to reduce that to a 2/5. So the first fraction becomes a 2 root 2 over 5. That second fraction, I can divide a 3 out of top and bottom. And so my second fraction just becomes a root 3 over 3. Now I like that because that means that my common denominator is going to be 15. And now I can pretty quickly multiply the first by 3, multiply the second by 5. We come in there, we notice we have no common factors. We are simplified. Okay, I am hoping that for today's topic, you've gained a little more confidence in the process of rationalizing, and we've moved past kind of doubt with our radical operations. They're pretty automatic by now. That what today became was, okay, can I have some strategies to be able to work my way through simplifying? Jump in, get some practice, knock out these, and let's make sure that we're really automatic with all of our radical operations. Okay, good luck.